The next thing I want to talk about is centripetal force. Centripetal force is a force that makes a body follow a curved path. And this is generally the cause of circular motion. In simple terms, centripetal force is defined as a force which keeps a body moving with a uniform speed along a circular path and is directed along the radius towards the centre. So if we tied an object to a piece of rope and spun it round and round and round, there would be a force acting towards the centre of the circle along the string. Now if you release the rope, the object would obviously fly off. Now this is key, in a straight line. It would be a dead, if you suddenly let it go, it wouldn't go circle, it would go in a dead straight line. Now how do you determine the centripetal force on an object being spun around? Well, this is the formula here. F equals m times v squared divided by r, where F is the force in newtons, m is the mass in kilos, v is the velocity in meters a second squared, and r is the radius. So if we spun a 1 kilogram object round with a piece of string 2 meters long at 12 meters a second, what would be the centripetal force? Well, if you put in the known variables in there, you get a force of 72 newtons. This is similar to the force that keeps a roller coaster on the tracks when it does a loop. If it went round really slowly, what would happen to the people in the carriages if they were not strapped in? If it was really, really slow on a loop, they'd fall out. But what happens is, because it goes so fast, it keeps people in. It's a force that keeps them in. If it was really slow, really slow, it went upside down in a loop, people would fall out. This is also the principle of a centrifuge. This is used by astronauts to get the feeling of a rocket taken off. Now, if you spin a centrifuge, it increases the force on the astronaut. So let's work out this effect then. If someone was in there, took an astronaut, and you kept spinning them, let's work out this effect here. What is the force on a 100 kilogram person at 1g? 1g is the force of gravity. Just stood on the earth, well, it can be determined using F equals ma, which equals 100, because it's a 100 kilogram person, times the force of gravity, which is 9.81. So the force of that person will be 981 newtons. So that's just the force just stood there. The force on a 100 kilogram person stood there on the planet is 981 newtons. What if that person was spun in a centrifuge with an 8.8 meter radius at 10 meters a second? What force would act on that same body now? Yeah, what would it have? Well, this is a formula here. F equals mv squared divided by r. You put in your known variables, it's going to give a force of 1,136 newtons. This is the weight that the person will feel themselves weighing. Don't forget, what's the difference between mass and weight? Mass is the same. I always have a mass of 70 kilos. Believe me, I do. 70 kilos. The weight, which is the force of gravity on me, is 70 times 9.81, which is about 680 kilos, 681 newtons. Now, if you go to the moon, it's different. It's different forces of gravity. Now, the weight is the force on it. Weight is based on how much gravity is in the area that you're in. Now, sticking this person into a centrifuge, what you're doing is you are able to make them feel heavier than they really are. So, how much gravity is his body feeling? Well, we determined earlier that the body experiencing gravity alone would have a force of 981 newtons, and in the centrifuge it would be 1,136 newtons. Well, this is equivalent to 1,136 divided by 981, 1.16 G. Do you understand when they say how many G forces it is? Well, what they're saying is he actually now is 1.16 times heavier weight on his body due to gravitational forces. Now, what if you increase the centrifuge to 20 meters a second? So, same person, 100 kilogram, spun him in a centrifuge to 20 meters a second. Put him in here, it gives a force of 4,545 newtons. How many G's would this be? Well, it's 4,545 divided by 981 equals 4.63 G. 4.63 times heavier. That person would feel as though they weighed 4.63 times what they did before. But that's what an astronaut feels when he takes off with speed. Centrifugal force, 4.63 times heavier. This isn't far off what astronauts feel when they actually take off. They actually feel about 5 times when an astronaut takes off, and that force on their body as it takes off with the force, they will normally feel about 5 times heavier than they do when they're not moving. That's what it is. That's the force of centrifugal force.